So hello everybody. In our previous session, we have discussed term that is what exactly language is. Language is. Okay. So in this session also we'll just continue with same topic. Okay. So let us revise point. See, initially we have discussed what exactly alphabet is. Okay. So if you have not yet gone through our previous session, then I request you all to please do watch our previous session first, okay, and then proceed with this one. Okay. So what is alphabet, or rather before that, how we denote alphabet? We denote alphabet by using Greek letter sigma. Okay. And what is alphabet? Alphabet is a finite set of symbols. Okay. Symbols can be anything. It can be character, it can be number, it can be any special character. Okay, it can be any mathematical operation or so on. Okay, so here see, our final aim is to discuss what exactly language is and how we can define different languages on alphabet sigma. Okay, so here I am just taking one example of alphabet sigma, which contains two symbols in it. Okay, first one is A and second one is B. Okay, then see, in our previous session we have already discussed, after defining alphabet sigma, later on we can define some string okay, on this alphabet sigma. Okay, so what is string? String can be any combination of symbols which are present in alphabet. Okay, so see, A can be treated as one string. Okay, B can be treated as another string, or A B can be treated as one more string, or A B B can be treated as another string. Okay, or B A B can be treated as another string. Okay, so we can define infinite number of string on alphabet sigma. Okay, so getting what exactly string is, see, this point we have already discussed in our previous session. Okay, so still if you are finding any difficulty, then please do watch our previous session first. Okay, so here A B B or any combination of these two symbols can be treated as string defined on this alphabet sigma. Okay, then we discuss one more term in our previous session, that is what exactly language is. Okay, so what is language? Language is a set of string that we can define on sigma. So if we create a set of all such string, then this set is called as language. This set is called as language. Okay, so I hope this point is clear to you. Okay, now, so because we have again already discussed this particular point, language, in detail in our previous session. Okay, now see, in this session we will just discuss one more point related with language. Okay, that is, see, language can be sometime finite or sometime it can be infinite. Okay, so in this session we will just discuss what is difference between finite and infinite language. Okay, now see, before proceeding with finite and infinite language, here we have to discuss one more point. Okay, that is how many languages we can define on given alphabet sigma. Here see, I have just mentioned one general language. Okay, now sometime you may get question. Here I am writing one question. Okay, define language of length 2 on sigma. Okay, where sigma is what? Where sigma is containing two symbols in it, A and B. So read this question once again. Define language of length 2 is mentioned here. Length 2 on what? On sigma. And what is sigma? This is our sigma. Okay, so if this is the question, Then how we can define that particular language? Suppose that language is denoted by using letter L1. Okay. So what is the condition given? The length of that language must be 2. Means here we have to form a string whose length will be 2. So how many possible strings are there whose length will be 2 of this particular sigma? See, first one is AA. Okay. Then AB. Okay. Then one more you can take BA, or last possibility is BB. Okay. So how many possible strings are there? 4 possible strings. Okay. All possibilities we have covered. So see, this is finite number. So this language L1 is called as what? This language L1 is called as finite language. Finite language. Or see, if we will just take one more example. Okay. One more example. Suppose again a question is given like, say suppose define language of length 1 on alphabet sigma, where sigma, let us assume that sigma is same, which contains 2 symbols in it, A and B. Okay. If this is the question, then let us denote that particular language by using L2. Okay. Now if this is the question, then how many elements we can place in that language? How many strings are possible on this alphabet sigma of length 1? First is A and second is B. Only 2 strings are possible. Okay. Getting this point. Now what will be, see, in our previous session we have already discussed length of language term as well. Okay. So how we denote length? The length of, suppose I want to denote the length of this L1 language. Okay. So how to denote this? Determinant of L1. And how to calculate length? How many elements are there here in L1 language? 4. Okay. So what is length of L2 here in this case? It is how many elements are possible of length 1? 1. Sorry, not 1. It is 2. Okay. Similarly, if you get question like define language of length, say suppose 3 on sigma. Okay. Then how to write that particular language? Suppose that language is denoted by using L3. Okay. So how many strings are possible of length 3 of on this particular sigma? See, let us identify. Okay. A will be first string. Okay. Then B another string. Okay. Then B can be treated as one more string. Okay. Then B. Likewise, if you calculate, then you will get 4 more strings. Okay. So total strings that you will get, you can identify. Okay. Different combination. Okay. Of length 3. So total if you calculate, then you will find that the length of this language L3 will be 8. Okay. Now see, in first language L1 length is what? 4. Then L2 length is 2. Then L3 length is 8. Okay. So fixed number is there. That's why L1, L2 and L3 are finite languages. Okay, so getting this particular point, why L1, L2 and L3 are finite languages? Because in that particular set, finite number of elements are there. Okay, now I just want to discuss one more example where language will be infinite language. Okay, now let us assume next question number 4. Okay, let us assume sigma for that as same. Sigma is A comma B only. Okay, suppose question number 4. Okay, if question is like, suppose define language which starts with A on sigma, okay, where sigma is same, okay, A comma B. Let us read this question once again. Define language which starts with A on alphabet sigma, okay. Starts with A means language means now it is very clear. In language, suppose L4, okay. Language means, as I said earlier, it is a set. Now that set must contain element which will satisfy this condition, okay. So in this particular set we have to write such a element which will starts with what? A. So what will be first string? A only, okay. Starts with A, only A can be considered, okay. Or A, B also we can consider in this, or A also we can consider, or A, B, B also we can add in it, okay. Or A, B, B also we can add, okay. Now starts with A. Now as far as this question is concerning, in this question there is no restriction on length of this particular string, okay. Only which condition is given? You have to identify language that starts with A, okay. So such how many strings we will get? We will get infinite number of strings, okay. So here we just cannot see, if you want to add one more element, you can add one more element like this, A, B, B, like this, okay. So such an infinite number of strings we can write, okay. And that's why here this language L4 is what? Is infinite language. Whatever examples that we have discussed earlier, L1, L2, L3, those are finite because in that particular set finite number of elements were there, okay. But in this language infinite number of elements are there. That's why this is an example of infinite language. Getting this point? Okay. So let us discuss one more example, okay. Now suppose we have to define a language. Define language that starts with let us say BA, okay. They may give any condition. Initially only A is given, now BA is given. So how to define this? L5, okay. You have to just take care of this condition while writing elements in this language. So very first string will be BA itself, BA, okay. And then in front of BA you can write any combination. BAA you can write, BABB you can write, okay. BABAB you can write, okay. But we just cannot write like AB in this because this will violate given condition, okay. So such how many elements we can write in this particular language? Infinite element we can write, okay. So that's why this language L5 is what? It is infinite language, okay. You can take any example, okay. Suppose again define language that starts with, say suppose only B, okay. So in that case L6 you have to just take care of this condition. Only B means B, you can start with B, then followed by BA, BAA, BB, BB, AB, okay. So such infinite number of element we can write in it, okay. So L6 is an infinite language. In fact here L4, L5 and L6 they are infinite language, okay. So in this session we have discussed what is finite language and what is infinite language, okay. So that's all for this session. Remaining part we will discuss in our next session, okay. If you find any difficulty in understanding any point, then you can drop me a message on WhatsApp. Otherwise you can ask your query on Google Classroom as well, okay. So stay tuned for further updates. Thank you.